All right, C, totally unrelated problem. The transmitter of electromagnetic waves is next to a long, straight vertical wall and acts as a plane mirror to the waves. An observer on a boat detects the waves both directly as an image from the other side of the wall. I didn't know. I didn't know that we had to construct images from plane mirrors. Oh dear. Do I need to add that? Dear Lord. Okay. The diagram shows one ray from the transmitter reflected at the wall and the position of the image. So basically, this thing is transmitting, right? Okay, and we're actually at this point receiving not only this signal that comes straight from the transmitter, but we're also receiving the reflection, right? The reflection is going to cancel and cause interference just like two double slits or two sources or two speakers would do. We've solved these problems. That's what's going on. So we can talk about that here. But let's go back to this. It says, demonstrate using a second ray that the image appears to come from the position indicated, right? What you want to do is take a straight edge and draw a line dotted here. It hits the wall there, and then, of course, hits the boat like that, and then connect this guy here. Do that with a straight edge, right? So basically, to form an image, we just need the intersection of two rays. So we just pick another spot on the boat. Now, to be honest, I actually had to do a quick Google search. I forgot plane mirrors, right? It's really pretty simple. But anyway, that's this thing. Oh, I don't know how to do that. I forgot. I haven't really taught geometric optics for a long, long time. Okay, let's see. Outline why the observer detects a series of increases and decreases in the intensity. Okay, so why do you? Well, because basically if it's reflecting off of there, it's just like, let's say it was dark, right? And this was light and that wall was a mirror. You would see actually two candles in the darkness. You'd see this guy, you'd see this guy, right? Now, these things are, of course, in phase because they're actually the same thing, right? And assuming that that the signal is of one frequency, right? Then as you move this way, you're getting to be different distances. And really, in reality, what's going on is that there's this path length and then there's this path length. You can imagine that, right? And when the difference in distance from this path length to this path length is one wavelength, it's constructive, and when it's a half a wavelength, it's destructive. So talk about that. See if you can get the marks for that.